Welcome back to this second part of this afternoon, where the theme is entrepreneurship and space, where we will give you various aspects on the relation between research, industry and government. And the structure will be, according to this program, first a 7-minute presentation, where we have 4 different speakers, and after each presentation I will bring up a panel here on the podium to make remarks and comments and put questions, and you will be invited, as Chris invited you, to take part in this discussion. And our first speaker is David Jarvis of the European Space Agency. Welcome forth, David. Please, I could make a 7-minute presentation of your personality and your distinguished career, but then there would be no time left for you, so I give you all these 7 minutes. Welcome.
Thank you very much. So thank you very much, everybody. Thank you very much to SNSB and also for Eva for our hosts for today. So it's a real honour to be here. In fact, I was here 2 weeks ago for another EVA meeting, so I'm becoming a bit of a regular here. On that occasion, I was given 37 minutes, so that was much more difficult. So 7 minutes will be fine. I'm going to fly through a few slides here. I've got the presentation which I put together called Unlocking the Innovation Potential, and particularly focusing on large integrated R&D projects. I should just add that I'm head of new materials and energy at the European Space Agency. So much of the technology that you've seen in the previous presentation, people like myself, the technologists and the scientists, we develop these kind of enabling technologies that allow space flight and the construction of spacecraft and satellites, and including the space station as well. So my job in ESA is to essentially develop the next generation of materials. That includes lots of alloys, high-tech materials, composite materials, how to manufacture them as well, and also focusing on energy systems, things like thermoelectric systems, energy harvesting, superconducting systems as well. So I'm just going to fly through some of those projects, but I don't really want to focus on the technology today, because I was asked to focus a bit more on the process of how to do this and the innovation angle as well. So I'm just going to list up some of the projects that I have worked on and we're currently working on. There are 6 projects that we have at the moment in our portfolio, many of which have been funded by the European Commission, and we have a total of about 120 million euros of projects running at the moment. They are in different areas, and you can see there from the list a lot of work being done on alloys, making new alloys and discovering them, how to do that rapidly. We're also looking at projects on thermoelectricity, where you turn heat into direct current. We're also developing large structures, titanium, aluminium, and new alloys for that. We're also looking at the next generation of nanocomposite materials based on aluminium and magnesium, where you add nanoparticles to strengthen them. And we've also got the world's biggest project on additive manufacturing, which is called AMAZE. And that's looking at metal products which can be 3D printed. Very large structures are being currently made, 2 to 3 meters in size, and eventually much bigger as well. So a lot of attention on some of these projects. And we're working very closely with companies. We have roughly about 65, 70 companies working with us at the moment, and that keeps on growing. They're very multi-sectoral, and I think that's one of the key things I'd like to mention in my presentation now is to do innovation, you can't just work within the space sector. It's very insular otherwise if you only work with space companies. So what we've done over the last few years is to team up with non-space industry as well. One of the things we've noticed is that we all seem to be looking for the same thing. We all want lightweight materials. So people who build aircraft have the same kind of interest as people who make spacecraft. There are lots of connections with high temperature materials as well. So people developing rocket nozzles, for example, they want the same materials as the nuclear fusion community. So of course it makes a lot of sense then to team up and to do sort of co-development of these technologies in a rapid manner. And of course, that multi-sectoral nature, so us as the space community working with aircraft builders, chemical producers, people in the automotive sector. We have projects running with Volvo, as an example. That's very important because it allows us to reduce the cost, reduce the risk, and also creates a kind of stable supply chain for the future. And I think one of the key things is integration. To do innovation well, you need to integrate very closely academia and industry. And if you can get the two different worlds to work in unison and get them to understand and respect each other and break down some of the usual barriers, you can get great results, and you can get the IP, the intellectual property, flows quite rapidly when you manage to unlock that and to bridge the gap. So that's one of the things that we work on a lot as well. And amongst those 6 projects, we've trained up a lot of people. We're very focused on a talent pipeline, and we've trained up about 100 PhDs and postdocs. And many of those, I'll explain on the next slide, many of those have gone on to good careers and become world experts and in some cases entrepreneurs themselves. We've developed about 30 plus patents, and that grows all the time. We've even created factories that didn't exist before to try and commercialize and market these different products. And we have several startups which are being created, including with ESA's involvement as well. So the idea of having a business incubation centre in Stockholm is very attractive, I think. Yeah, it's in Sweden, okay. So just a quick slide, the final slide, innovative R&D. This is my very simplistic way of presenting it all. What can you do? Where will you need to do it? Who do you need involved, and how as well? Starting off with the what. Clearly you need to have some radically different idea at the very beginning. You need something which is a game changer, ideally. And if you can change that game changing idea into a prototype, which you can also patent, and it's very important to secure IP on these things, then you're on the way to developing a product. And of course you have to iterate with your end users, the customers as well. But you may have a marketable space product, and we try to deliver that within the space of 6 or 7 years. So we go from an initial concept to a product quite rapidly. And of course, where does that get done? Well, in the early days, initially, these things are being done in R&D labs at university level. And of course, then it moves towards standardized pilot lines to develop your product. And if it goes as far, you will develop industrial factories as well. And of course, going back to the people, of course, the who, the European PhDs and the research fellows and the postdocs that we're training up, well, these people are now becoming world-class experts in their particular field. And we're very proud to be able to train up these people, not that, so that they're completely specialised, that they have a good overview as well. But eventually, and a handful of them will turn into commercial entrepreneurs. Now, it's not for everybody, and you have to have a certain kind of skill set, and you have to be a rather dogged character to be able to become an entrepreneur, but some people do. And I think all of that is wrapped together nicely now. The key ingredients for entrepreneurial innovation, and I've highlighted a few here, having the ability, or foresight, the ability to look into the future, the kind of Steve Jobs type vision, where you can see what do people want in 10 years from now? What kind of products do people need? What does the market need? What does our space industry need? And of course you need creativity. People need to generate new ideas, make connections between different technologies, and that's part of creativity. Passion is probably one of the most important aspects of any entrepreneur, is they must love what they do. And just, I know people who get speeding tickets as they drive to work. Most people are trying to escape work, but I know people who've got speeding tickets going to work, so that's usually a sign of passion. You need to be quite fast as well. You don't want to hang around too long. There's a lot of competition in the world, also on the US and Chinese side, so you do need to be fast and not too slow and bureaucratic. And I think the last and probably the most important thing to say is you need to be quite grumpy. You need to be unhappy generally with the status quo. Now, doesn't mean that you're not optimistic, but you do need to be a bit unhappy with the status quo so that you want to improve things. And that really is a kind of good driving force to get you forwards as well. So these are the key things that I've kind of highlighted in my 7 minutes. I think the final thing to say is go forth and innovate.
Excellent, thank you. Thank you. Set a good example. It was 6:55:42, so it's
military precision. Yeah.
Your theme was unlocking the innovation potential, and you also said if you can make them. Can we learn anything by asking why has a system been locked?
Oh, there's many reasons for that, yeah.
But if we find out these reasons, I mean, it would be easier to find the keys to unlock the innovation process.
Yeah, absolutely. I mean, first of all, you need to work in an organisation that kind of fosters and encourages innovation. And you'd be surprised, even some quite large companies can be rather difficult to work in. A lot of bureaucracy, and we were discussing this over lunch with a few colleagues, and it doesn't only apply to governmental organisations, even big companies can find it difficult to innovate. And I think you need to identify in your organisation who the most creative people are, and to allow them to flourish and take the admin off them, take them away from the more day-to-day aspect, and allow them to be creative and be pattern creating machines.
How much have you achieved in this unlocking process, would you say?
Oh, it's difficult. I mean, I think we're on the way to becoming unlocked.
Do the prisoners know that the sentence is over?
So, yeah.
I mean, have you created an awareness about the openness, the possibilities?
I think, we try our best to disseminate what we do. I mean, I run a group of about 10 people within ESA, and we practice what we preach here. But of course, that's not always, you can't transfer that to every area of an organisation. But it's good to identify the key areas and to try and let them flourish, I think, yeah.
You described innovative research and development as going from idea to prototype to product. Even more innovative developers go the other way. They find the end user and his or her needs, which means that they will take part in shaping the product and taking part in the financing.
That's pretty much what we do as well. I mean, you have to have a huge dialogue with the end users and your customers. Who wants your product and why are you developing it? Only when you've got the discussion going can you actually understand what they want, and you might have to tweak what you're doing or change the company strategy. And it's also very important to understand and talk to the people that don't like your product, because that will also unlock the future. So it's important to talk to your existing customers, but also then likewise the people that don't care about your product at all.
I mean, why inviting our panel, which is Christer Fuglesang, please come up, and Michael Lopez Alegria, please, and Jan-Erik Sundgren of Volvo, and Betty Malmberg, who is a member of the Swedish Parliament. And I'm most curious about you, Betty, because I've never met you before, never heard you say anything. Why are you interested in space?
Well, don't know, actually. Yes, but I'm interested, and there's a lot of MPs interested because of, I think, the innovation possibilities we see in this area. And so that all of you know, we are 349 MPs in the Swedish Riksdag, and we are about 55 that are members of this network or this association in the Riksdag. So that's quite a lot of them that actually take part. And I also work and are responsible for questions dealing with research and education. And therefore, I also find and recognize that a lot of the people that dealing with research do have some do exist in the organizations that deal with space. So it's rather a lot. We saw from Ms. Jarvis' presentation here that you had fostered around 150 or something postdocs. So it's quite a lot. And I do believe that this is an area that we need to put more efforts in. In the Riksdag we're now talking, and also the government are talking about putting a space agenda on to really know and to really see what we are going to do. And I think we need this because we are good at these questions, but we need to have a broader look at everything so that we really do see the overarching.
But these
system.
parliamentarians who are in the space network, you
Yes.
said they are also interested in innovation. Do they see space innovation as a part of the general picture of innovation in Sweden? Because my idea is that we're talking a lot about innovation, but very little about space, industry, space research, space innovation.
Yes, that's true, but I think that we get so many interested in the space network is because that space concerns so many different areas, like from everything from astronomy to right innovation. And we had this seminar just a couple of months ago in the Riksdag, where we had a knowledge seminar for the people on the Committee on Education. And that was a brilliant opportunity for the MPs in the Committee on Education to actually see what the space innovation can result in. And that was a real good presentations that we got then. And there's a lot that really sees the innovation magic that is in space. Yes.
Jan-Erik Sundgren of Volvo, when you saw these projects that David presented to us, which of them are of interest to Volvo?
I think all are of interest to Volvo. You mentioned additive manufacturing, lightweight material, thermoelectrics. Anything we could do in energy harvesting would sort of improve the EV automotive sector and commercial vehicles. I mean, I come from the commercial vehicles part, so there are certainly interesting issues.
Are they at a point when you're interested to cooperate and finance and be a part of it, or do you say, hey, we'll wait a minute to see if these guys succeed before we go in?
No, as you heard, we are part of these type of projects, and we are part of the projects out of this specific reason that we think that they can contribute to our business and our future business. And up until a year ago, we even owned a company that was involved in space activity. We owned Volvo and we learned a lot from making nozzles to the Ariane rocket and part of the hydrogen fuel pump. So we gained a lot from that type of experience. So obviously this is a very interesting area, and I have a few questions to David, but I can come back to this.
Because sometimes we describe it as a gap between research and innovation and industry in Sweden. We have difficulties in closing this abyss that you have to pass. Is Volvo prepared to sort of go backwards or forwards or whatever you like to meet David on the way and say, can we help you?
But I think what David said is part of our philosophy as well. If you're going to do something in a new area with a long time horizon, because we are not talking about next year or next quarter, because those things we do ourselves. But if you do that, talking about a long time horizon, you really need to secure that you have teams composed of different people, different cultures, different background, different disciplines. That's how you foster innovation. And why would I ask a question to David? You said that you train entrepreneurs and you have these excellent researchers that eventually becomes entrepreneurs. But when you learn to swim, it's definitely an advantage to have water already from the beginning, right? And I think it would also be an advantage to have entrepreneurs involved in the process already from the beginning. People that have done, and are not scientists, but are really entrepreneurs. They should be involved in already from the beginning, and you didn't mention that. So my question is, how do you think on those issues? You gave an impression that you have a linear process, and they eventually evolve to become entrepreneurs.
I think it's probably a bit more cyclical than what I described in the picture. There's one example.
And hold it, place it on your chin. Just
there we are.
Yep.
Exactly. Yeah, there's an example in the Thermomag project on thermoelectricity that Volvo's also in. And there we've had some strong interest from entrepreneurs who we've brought into the project. So there's a multi-billionaire from Norway who's very interested in commercialising this kind of technology. So wherever we can, we do try and attract some key business industrialists who've got a track record in So we try our best to do that, so it's not as linear maybe as my simple
It,
diagram.
it sounds very easy, but there might be a conflict in this. Researchers want to understand things, and entrepreneurs want to achieve a result.
There's a very difficult balance, especially in these kind of large, multi-centre, multidisciplinary projects where you've got academia and industry, and they need to get along somehow, otherwise you've got legal disputes every single day. So somehow you have to balance all of these different forces and different expectations. But somehow we manage to get through that, and we have some reasonable success at the end of it.
Mm.
But isn't it the case, when you bring academia and industry together, which I think is a good idea, and we try to do that all the time, you both want good science as well as something that is turned out into something usable and maybe eventually into an innovation?
That's right. I mean, some people often use the distinction of like basic and applied research. We don't make that distinction at all in our projects. It's either boring or really, really interesting. That's the key distinction.
We don't like that the basic and applied research. We distinguish between very good research and mediocre research, and we don't like mediocre research.
We have come beyond that, finally.
Kirsten, is there anything new in this, or have you heard this ever since you first saw a star and the moon on the sky?
First of all, I don't think you see it as well structured as David presented, but of course it doesn't help to have all this structure. You need a brain and a capacity behind it, and that's kind of what David proven to be, that he can put the pieces together, not only have.
To put your microphone on. He's not going to pickpocket
Does it
you.
work now? All right. All right. So after all, it's also about having the right people and having them to interact smart way, and that's what I know David is doing a great
But
job.
is this a new approach, according to you?
Well, I think it's presented in a more structured way than you normally see.
Okay.
But of course, the process has been going on for a long time. And I would like to ask David a question. I mean, all these steps there, is there one particular which you find more difficult than the others? Is it getting an idea or getting the money?
Well, yeah, there's always a struggle internally within any organisation. Of course, you have a lot of hoops to jump through, a lot of admin, and also dealing with the European Commission is not always the easiest piece to. People are already chuckling already. That can be quite bureaucratic sometimes. So that we need to reduce somehow the paperwork involved in research, and also give scientists and researchers a bit more trust, because a lot of the systems in place today are very sort of. You feel like you're a criminal or something, when you're spending the money, and therefore you have to be audited down to the last euro cent, So it's a bit, disproportionate administration for the work we're doing and the added value that we're adding to society. So I think a trust-based system would be much more preferable than the system that we have at the moment.
Mm. Michael, is David's success of use to commercial space flights?
Well, I think certainly, no doubt. I mean, anything that brings advances in materials or processes. I was very curious to know. I mentioned that materials are one of the things that makes spaceflight so expensive. They're very exotic. They're hard to manufacture. They have to be very manufactured at very tight tolerances. Have you seen anything that is sort of disruptive in the materials world lately?
I think the additive manufacturing project that we've set up, AIMS, that's probably the one that's got the most disruption to it, because we're already making some components now which are probably 50% lower cost than the conventional technology. So when you use additive manufacturing and you do 3D printing, you're placing the material where you need it and where you want it without too much machining being required afterwards. So to be able to 3D print a complicated component and still deliver high quality and reliability, that's a game changer. So I would say that I'll pick that one out as being probably the most useful, certainly for the space sector, but also for aeronautics in general.
Peter, I must ask you, is space research good in itself to Swedish parliamentarians, or is it good only because it's a more general use to other kinds of research, innovation, education and so on.
We do have a track record that says that our space research is good. But of course, I think that most parliamentarians see this more like a future area and also see what it contributes to in other areas.
I mean, is it strategic in itself?
It's a strategic question, absolutely, yes.
Audience, please take part in our discussion and conversation.
May I just ask
Yes.
about those companies that you cooperate with? You said it was about 70. Is there all large companies like Volvo, or are there SMEs as well?
Yeah, plenty of SMEs are involved as well. It's probably maybe 50% large multinationals and then 50% SMEs of varying sizes. We'll work with anyone who's got interest in technology. It's a two-man band somewhere in some small micro company, but with great potential, we'll work with them as well.
So you served as an icebreaker previously. Your first question brought forth a sally of other questions. Can you maybe think of something this time as well?
I guess my impression has been that the space technology has been very much driven by its own conquest, so to say. We want to conquer the space, and we have developed the technology because we want to do that. But then we also seen, as I said before, that the communications industry, of course, can benefit a lot from this technology. We've seen that. So what I thought before was just to ask if there is any other kind of industrial sector that can see a high potential for itself, so to say, to use.
Betty, have a try this. So why is space research, development and industry important to Sweden?
Well, because this is an area, we're a company or a country that depend a lot on export, and therefore if we have the knowledge and we do it well and make a lot of innovations, of course that's a good benefit for us.
Innovations besides communication.
Besides communication, yes.
Such as?
Oh.
Christer comes to the rescue.
I mean, there's a lot of applications of space in addition to communication. You have weather satellites and the knowledge we gain from Earth's observation that's help us all the way from understanding the climate question to better forecast on how our forests are doing and to predict bad harvests, something where all the navigation you're doing, the GPS and Europe, we just now launching our own global navigation system called Galileo, and we're hoping there will be a lot of applications added to that. So while I can add on a lot, but maybe a few examples.
I have a question to Mr. Jarvis related to manufacturing. One of the long-term dreams has always been to be able to have manufacturing in microgravity in relation to the exotic alloys, for example, that you've been doing research on. Do you see something on the horizon?
Good question, because we have a project on that actually. I can't mention methodology because we've just applied for a patent on it, but we are developing a 3D metal printer for the space station. We're going to test it on parabolic flights first, and then once that goes well, we'll probably transfer it to sounding rockets, and then eventually to the space station itself. But we've devised a new method which is low when it comes to power consumption, and it should be able to print light alloys like aluminium in microgravity environments. So that will allow us to make parts in orbit on demand to allow astronauts to make things or repair things. So that'll be a new capability that we're going to deliver.
Jan-Erik?
I think I was very happy to see that European Space Agency had a focus also on manufacturing, because I think manufacturing is crucial, and we see a renewed interest in manufacturing, and that I think is good both in Sweden and elsewhere. In US there is a large renewed interest in manufacturing, and if commercial space flights is going to sort of be not available not only to those that have a lot of money, then you need really new type of manufacturing technologies for the new materials that are developed. So I think this is a crucial area that we are now seeing a renewed interest in.
I could add to that and to say that I mentioned before that one of the companies that has been able to achieve fairly dramatic cost reductions has been SpaceX. And I mentioned that they're very vertically integrated, meaning they do a lot of their own manufacturing. And what I learned was that they actually went to the auto industry and got some experts on assembly line manufacturing and brought that in-house. So it's interesting to see the technology and the processes are going both ways.
And they have a 3D printing device themselves also, by the way.
Thank you this far, panel, and you will be back after our next speaker on the stage. Thank you.